Hi, this is Presh Talwalkar. Fermat and Pascal once considered the following coin flipping game. Every time a coin showed heads, 1 point would be given to Fermat, and every time it showed tails, 1 point would be given to Pascal. The object of the game was to get to 10 points, and that person won a prize of 100 francs. As they were playing, the score got to 8 points to 7 with Fermat leading, and they unfortunately had to stop the game and couldn't resume it in the foreseeable future. They agreed that they would split up the prize fairly according to the probability that each could win the game. The problem to you is, how did they split up the prize? If you take in probability, this problem might seem easy to you, but you have to remember this problem came up in the mid-1600s, actually between Fermat and Pascal in correspondence, before the theory of probability was actually fleshed out in detail. Their correspondence actually led to some fundamental concepts being developed in probability theory. So give this problem a try, and when you're ready, keep watching the video for the solution. Fermat came up with a very ingenious solution. He imagined that when the score was 8 points to 7 in his favor, the game would end for sure in 4 coin flips. Now the game might end earlier in 2 flips or 3 flips, but for sure we can imagine if we flip the coin 4 times, we know that the game would end for sure. So Fermat said, why don't we consider all 16 equally likely sequences of 4 coin flips and see the number of cases in which he would win and the number of cases in which Pascal would win. Now if there were 3 or more tails, that would mean a victory for Pascal. There are 5 cases for that. The remaining 11 cases would be victories for Fermat. So Fermat deduced that there's an 11 out of 16 or 68.75% chance that he would win the game. So he should be awarded 68.75% of the prize. Now this solution is correct, but since it doesn't always make sense for people that you extend the flips out beyond the game ending, I'm going to show you another way that you could solve this problem. So imagine the game is tied 9 points to 9. What's the probability that each player is going to win the game? The answer is each person has a 50% chance of winning because the coin is equally likely to show up heads or tails. And this is going to be true whenever the score is tied 8-8, 7-7, and so on. Anytime the score is tied, there's an equal chance that either player is going to score a point, and therefore either player has a 50% chance of winning. So now let's consider another situation. What if Fermat is leading the game 9 points to 8? What is his probability of winning the game? Well, there's a 50% chance he might flip heads at this point, and he'll win the game at 10 points to 8. So for the 50% chance contingency the coin shows heads, there's a 100% chance that he would win. There's a 50% chance the coin would also show tails, in which case the score would go to 9 to 9. And we just argued that would be a 50% win share for Fermat. So we can calculate the win share at 9 to 8 by combining the contingencies that could result. If we average out the 2 contingencies and the probability of winning in each of those, there is a 75% chance that Fermat wins the game with the score of 9 to 8. By symmetry, that would mean there's a 25% chance that Pascal would win the game when Fermat is leading 9 to 8. So we can also say that when Fermat is losing 8 points to 9, he has a 25% chance of winning. And we can also calculate that by averaging out the contingencies. So let's imagine now the game is 9 points to 7. Well, if Fermat gets a heads, then that means he's going to win outright. If he gets a tails, the score is going to go to 9 to 8, and we just argued that's a 75% win share for him. So we can average out these 2 possibilities and calculate that his win share at 9-7 will be 87.5%. Finally, we can get to the problem we wanted to solve, which is, what if the game is 8 points to 7 with Fermat leading? Well, if the coin shows heads, that's going to get to a score of 9 to 7, which we just calculated was an 87.5% win share. And if the coin shows the tails, which happens with 50% chance, then the score goes to 8-8, where Fermat has a 50% win share. So averaging these 2 contingencies, we see that Fermat's win share at 8 to 7 is 68.75%, which is the same conclusion that Fermat found out by imagining flipping the coin 4 times and calculating the number of sequences in which he would win. So both methods are a valid way of solving this problem, and whichever method makes sense to you is fine to use. Did you figure it out? Thanks for watching this video. Please subscribe to my channel. I make videos on math and game theory. You can catch me on my blog, Mind Your Decisions, which you can follow on Facebook, Google+, and Patreon. You can catch me on social media at Presh Talwalkar. And if you like this video, please check out my books. There are links in the video description.